Agile companies have three traits. They learn fast, they make fast decisions, and that whole process is supported by enabling technologies. And for us, Wolfram language and SystemModeler are the enablers for things that you wouldn't normally expect a small business like us to be able to get engaged in. I'm Robert Prince-Wright, Managing Partner of Berkeley Imperial. We're a safety and systems engineering consulting company. We work in the oil and gas industry. Most of what we do is focused on supporting development engineering and operations for oil and gas facilities. Probably the last 5 years we've focused on working with high technology applied in the Deepwater drilling industry. So Wolfram technologies actually allow us to develop a workflow which starts with the thought process which we record in notebooks, where we build models, we test the models to make sure that they behave like the real thing, we can calibrate them. But once we've gone through that modeling process in notebooks, what we then do is we write the code in Modelica language, which is the language used by SystemModeler. We chose SystemModeler because it's integrated with Wolfram language. And what that means is that, as I say, we can develop models, we can use those models, for example, in Monte Carlo simulations to generate states for the system, and then feed those states into SystemModeler. And that is a fairly unique feature, I think, of the Wolfram language and SystemModeler system. A key feature for us of SystemModeler is the ability to interrogate the model, and in particular, check the equations and how they're organized within the sort of matrix form before solution, because any large complex system is relatively difficult to build and debug. But with the features that are included in SystemModeler, that's now easier. We believe that SystemModeler is probably the best interface to allow you to build Modelica code. We've had some success building virtualizations of, for example, digital drilling rigs. And the pace at which we've actually done that, we've taken about a year and a half or thereabouts to build a model that I know others have spent years developing. And in large part, that's down to a combination of being able to prototype the models in Mathematica, and from that stage then go on and actually code it in the Modelica language within SystemModeler. And generally that workflow, I think, is relatively streamlined and has enabled us to do stuff in timeframes that I think most people would be surprised by. I think the beauty of the process is that the control is given back to the engineer, and that's very important. If you can keep the engineer engaged right from the very beginning, the conceptualization right the way through to exporting embeddable code, it's faster and there's less likelihood of making mistakes. I've often heard clients say that the way we've solved problems, the way we're presenting solutions has been excellent. And I think a large part of that is the graphics and the notebook interface, which allows you to present results in a way that can be, let's say, dynamic in a manipulate, or presented graphically in a way that would be relatively difficult if you were trying to use a spreadsheet or something else. But clearly the language enables certain things, and those things convey solutions in a way that I think is fairly unique. The evolution of from Mathematica version 1, which I started using back in 1988, through to where we are currently, has been very carefully designed to ensure that the core language really was honoured right the way through the process. And that's because it was so well thought through at the very beginning. And what that means now is that using Wolfram language gives you an opportunity to solve even bigger and more complex problems. But in particular, what's happening now is they're integrating the language with the real world around us. So for example, the idea that you can write code in Mathematica or export it to SystemModeler and then from there embed it on a microcontroller is pretty remarkable when you think about it. It means that that core language basically back in '88 is now heading towards what might be the state of the art for embedded solutions.